This will be a lesson for AP Physics B 1998 explanation. But before I start that problem, I want to go over this formula one more time. This is in our lessons, and it shows that there is a dependence between the velocity of an object and the tension in the string. So, and the relationship can be expressed through this formula, where velocity is equal to the square root of the tension in the string, or force in the string, over the mass per unit length coefficient. So this mu is mass per length. Sometimes you will see mu in the denominator. Sometimes this can be mu in some books. And sometimes you will see just mass over unit of length unit. So just before I start this question, next one, I'm gonna show this formula to you, and I want you to know that many questions wave related will include A or B or C or D question related to this formula, and it's not given on AP exams. So here is 1998 AP Physics B question. To demonstrate standing waves, one end of the string is attached to a tuning fork with frequency 120 Hz. The other end of the string passes over a pulley and is connected to a suspended mass M, as shown in the figure. The value M is such that the standing wave pattern has 4 loops, the way it's shown. So there is 1, 2, 3, 4 loops. The length of the string from the tuning fork to a point where the string touches the top of the pulley is 120 meters. So this length, or this one, is 1 meter 20 centimeters, 1.2 meters. The linear density of the string is the density of the string. So what they give you is mu is it's the mass per length measured kilogram per meter, and that looks like 10 to the negative 4 kilogram per meter, and remains constant throughout the experiment. Determine the wavelength of the standing wave. So because the length of the string is equal to 1.2 meters, or a meter 20 centimeters, and we have two full wavelengths, 1 and 2. There's 2 wavelengths. So the wavelength is 1/2 of the length of the string. So that is 0.6 meters, or 60 centimeters. For the next question, they ask you, determine the speed of transverse waves along the string. The speed, the formula of the speed is equal to lambda, the wavelength, times the frequency, or lambda, the wavelength, over the period. And because they give you frequency, I can say lambda is 0.6, frequency is 120, so that is 72 meters per second. The speed of waves, for C part, the speed of waves along the string increases with increasing tension in the string. So the speed, the formula that we just looked at, so the speed depends on the tension and mass per length coefficient. So the speed of waves along the string increases with increasing tension in the string. Indicate whether the value of M should be increased or decreased in order to double the number of loops in the standing wave pattern. So if your velocity increases, so if the tension increases, causes velocity to increase. Velocity is equal to wavelength times the frequency. The frequency is set and doesn't change. The frequency depends on your tuning fork. So that one is set and doesn't change. So your wavelength will increase with the increase of the velocity. So the question is, indicate whether the value of M should be increased or decreased in order to double the number of loops. If you want to double the number of loops, then you want, so if this is the length, and right now you have 4 loops, but you want to make more loops, the wavelength is going to be shorter than it used to be. So before, your wavelength would be this much. Now your wavelength is this much. So the wavelength must be shorter. If the wavelength is shorter, then you have to have velocity smaller. To cause less velocity, you have to make the mass smaller. So the answer for this question would be to decrease the mass in order to make more wavelengths, or more loops, the way they call it. For D, they ask if a point on the string at an antinode moves a total vertical distance of 4 centimeters during one complete cycle, what is the amplitude of the standing wave? So if this is the wave, and this is your antinode, the point is gonna move this distance, this distance, this distance, and that distance to complete the full wave. So it's gonna go down and then come back. So this part, this part, this part, and this part is all together 4 centimeters. How much is this part? Must be 1 centimeter. So the amplitude is 1 centimeter.